Hello guys, I am Lavanya Vanga. I love to explore how AI can understand patterns in the data. So today I will introduce you to one topic which is recurrent neural networks. It is a key concept in teaching machines to process the sequences. So let's start. Okay, so we will explore a fascinating concept in a deep learning called recurrent neural networks. Have you ever wondered how your phone predicts the next word when you're typing the message, or how smart assistants like Alexa and Siri understand your voice? That's where the RNN comes into the play. In this session, we will break down what is a recurrent neural network, how it works, and why it is used when we deal with the data that comes in a sequences like text, speech, or time series. Let's start by understanding what exactly an RNN is. In simple terms, an RNN is a type of a neural network that is designed to work with data that has an order, like sentence, speech recording, or even a list of stock prices over the time. Unlike regular neural networks that treat each input as independent, RNN remembers what they have seen before. This is what makes them powerful. They have something called the loop in their architecture. This loop allows them to take what they have already processed and use that to help understand new input. For example, if a regular neural network reads the word I am, it will treat those words as individual units. But an recurrent neural network will remember I am and use that memory to better understand what comes in a next, like happy or tired. So it will predict the sentence as I am happy or I am tired, like that. Okay, now what makes RNN different and useful? The answer lies in their memory. RNNs are special because they have ability to store the information about the past. This means they don't just look at the current input, they also look at what came before it. Think of it like reading book. If you only read one word at a time without remembering the previous one, you will not understand the story. RNN works the same way. They keep the track of context, which help them to make better predictions or classifications. This memory, like a feature, is what gives the RNN an edge in a language processing, speech recognition, and more. Let's dive deeper into how RNN actually works. At the core of an RNN is something called hidden state. You can think of this as a container that stores what the network has learned so far. When the RNN receives the first input, say the word I, it processes it and stores the information in the hidden state. Then it takes the next word like I am and combines it with the hidden state to update what it knows. This process continues for each new input, so each time step shares the same function, but the hidden state keeps changing based on the sequence. This architecture allows the RNN to capture the flow of the information through time. It is as if the network is building a story in the memory as it reads input word by word. Okay, let me give you a simple and practical example. Suppose we give the sentence I am going to the dot 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 to the RNN. So based on the words it has already seen, I am going to the RNN might predict that the next word is a park or a store or a market. Why? Because it remembers the structure of the sentence. It is using what it has already seen to guess what should come the next. This is how autocomplete feature works on your phone or in apps like Google search. RNN help the machine to understand and complete the thoughts based on earlier parts of the sentence. While RNNs are powerful, but they are not without their problems. One of the main issues is that they struggle with remembering information from the earlier in the sequence, especially if the sequence is very long. Imagine reading a paragraph and trying to remember the first line after reading the entire page. It is not so easy, right? This issue in RNN is known as the vanishing gradient problem. When the model updates its weight during the training, earlier inputs lose their importance and the network tends to forget them. As a result, RNN don't perform very well when long-term memory is required. This is why researchers later developed improved versions like LSTM and GRU. So, where do we use RNNs in a real world? Let's see. There are many exciting applications. For example, in a speech recognition, RNN help virtual assistants to understand what you are saying word by word. In a machine translation, they translate sentence from one language to another while keeping the sentence structure. In the text generation, they help in writing paragraphs by predicting one word at a time. In a music generation, RNN can generate melodies that follow a pattern. And in the finance, they are used to predict the stock prices based on historical data. All of these tasks rely on understanding the order and flow of the data, which is exactly what RNNs are designed to do. Okay, let's wrap things up. Recurrent neural networks are deep learning models that are designed to handle sequences, right? They stand up because they can remember past inputs using structure called hidden state. This memory allows them to understand the context, which is crucial in a language, speech, music, and time based data. Although they do have some limitations, especially with long sequences, they remain an important foundation in the field of artificial intelligence and deep learning. Okay, thank you all for your attention. I hope this session gave you a clear and simple understanding of recurrent neural networks, right? So feel free to ask any questions or share your thoughts. I would be happy to continue the discussion.